Now that we have covered vectors in our CPU, let's move on to matrices. Now, I'm not going to introduce all of the ideas of matrices here. What we will do is we will introduce them as we go along. So all we want to do here is just get a little flavour of matrices. So here is a matrix, and it's a 2 by 2 matrix. So 2 by 2 means it's got 2 rows and 2 columns. Now, a basic idea of a matrix and why we use it is this example here. So let's say we were to multiply this matrix here with the matrix x1, y1. Now, in order to multiply these, we multiply rows by columns. So it will be 2 times x1, 3 times plus 3 times y1, and you get this linear equation here. And then it will be 4 times x1 plus 2 times y1, and you'll get this linear equation here. So it means that we can represent these sets of 2 linear equations very succinctly and very neatly within this matrix. So this is a nice, neat way for us to represent this bit of algebra. Now, usually whenever we see a matrix, it'll have a capital letter, and that's something we will follow through here as well. So here's another matrix, which again is a 2 by 2 matrix. It's got 2 rows and 2 columns. Here's another one, and this one is a 2 by 3 matrix because it's got 2 rows and it's got 3 columns. And generally we would say a matrix would be m by n. So that's the number of rows and n is the number of columns. So we want to be able to represent this idea of a matrix within our CPU. So let's go ahead just in this video, and it'll be a short video just to show you how we're going to represent it. In order to represent our matrices within our assembly language, all we do is we write the elements of the rows separated with commas, and then to get on to the next column we use a colon. So for example, if we were to generate this 2 by 2 matrix here, which is 2, 3, 4, 2, then we would write 2, 3, colon, 4, 2. And the colon just tells us that this is a matrix and the 4, 2 is the next row. And that's it, it's quite straightforward. So if we were to do the next one here, 1, 2, 3, 4, 5, 6, then it would be 1, 2, 3, colon, 4, 5, 6. So we can represent a matrix of any combination m by n rows and columns by using the colon to separate out each of the rows. What's important to understand here is that although we know that this is a matrix, and we know it's got 2 entries in the first row and then 2 entries in the second row, so we know it's a 2 by 2 matrix, in reality it's just another array as far as our assembly language is concerned. We're going to have a number 2 in one memory location, and then the next one memory location will be 3, and then 4, and then 2. So as far as our assembly language is concerned, we just have an array, and the position of the first element of the array, which is 2, is given by matrix underscore A, and matrix underscore A is nothing other than the first address. In this case here, it's 0 cross 8100. So whenever we pass this matrix into, for example, a subroutine, then we can just pass it in as it was we did previously with our arrays. We can pass in the starting location, and we can pass in the number of elements. So that's how we're going to represent our matrices within our assembly language. So let's move on in the next video and we will look at doing matrix addition. Thank you for listening. I'll get you on the next video. Goodbye.